objective. Please, you can keep reading what is here because I'm not going to be like talking about the bullet points. I'm just going to be describing APIs for you. Please, moderator, how long do I have?
You have about, let's just say 35 minutes max.
Okay, I think I can finish under that time. So an API basically, it could be an object, it could be an XML, it could be a query. In fact, these days it could be a remote something protocol, a gRPC. What do they do? Now, to understand what let's wait for that person. So to understand what an API does is just like this. How many of you have tried to apply on government workspace before? Like maybe Jam for instance. If you try to apply on Jam before, for all of you, for those that are veteran Jam writers, I wrote Jam like 3 times, so I'm a veteran. So if you had experienced some kind of a blockage on it, you realize that those kind of applications are mostly monolithic applications because once one part of it fails, every other thing fails. That's what a monolithic application looks like, and that was like what started the foundation of application development is monolithic. Everything is together. When you cannot log in, the other part, let's say, okay, you can actually log in. Once you finish logging and you try to do something else and it fails, the whole application crashes. It's because they are so linked, they are just one unit. So once any part of it fails, the other part crashes. But in order to remove that, in order to address that issue, APIs were introduced. APIs now became the bedrock of microservices, such that you can now build your parts into components, right? Then when you now build your parts into components, that is several APIs. Let me make it make more sense. Let's say you have an e-commerce site. So you build an API that will help you search. And that search basically will just be directing the user as he's putting a name. Let's say you want to search for Google Pixel 6. Once it puts that Google Pixel 6, the API behind the search button will carry that Google Pixel 6 into a query and go and query the database. Now, it is using the API to communicate with the database. Unlike what was there before, in the monolithic application, it is a giant query that is there. You put it, it will insert itself, now query the database. You understand? But with APIs, it became faster. Now, all those components are there, right? You've already seen the one that is doing search. Now, there is one that will do the adding it to cart. That means it will create like a catalog of events for the user. That's another API working. So it's so possible that search might not be working. It means every other thing is working. You can add to cart yourself, which means you don't need to search by using the search box. You could go to the category where the Google Pixel is and go and look for it manually without searching. Searching will only make it fast. So you see that the application will still be usable. That's what API begins to bring into the table. So all these things, all this jargon I'm writing here, that's me explaining what an API does. You understand? So now, like I said, it allows an application to have multi-directional communication. So which means I can be on a system and I can communicate with some parts if other parts are not working, and I will still be able to get the end result, right? Take for instance again, let's say search worked, you now go to payment, but there are like 3 forms of payment. Payment through card. It is an API that would reconcile that. Payment through, let's say, tokens, cryptocurrency. It is an API that will work with that. Then payment through your own wallet. Let's say you have a wallet on that particular application. It is not one payment API that would handle all of that. There might be a payment gateway. That is just it. Like a gateway means what, going advanced on what an API does. There's an API gateway that it kind of shields the other parts of which I will still talk about, it will shield the other APIs that are working internally. So it receives all the messages and distributes it to the right quarters. So which means if you are going to pick, let's say, payment by crypto, the API gateway will consume that API, resolve it. Okay, this is a crypto ID. Crypto, go and handle this. Does that make sense so far? Or have I confused you? Hello, does that make sense so far? Please let us make it interactive. You
Yes,
can
it
just unmute
does.
your
Yes, it
mic and
does.
say
Yes, it
something.
does. Yeah.
Okay, so that is what API essentially does. It compartmentalizes things for you and makes it easier for you to be able to interface. So now let us say we now have an holistic shopping app, right? But you now want
Hello,
to,
sir. Hello, sir. Hello,
yes,
sir. I think I feel or I'm pleading that you should break down your English for we that are just coming into the field, compartmentalize, interface, all these things. Fine, I've
okay,
checked the mini, but I need to be able to understand what you're talking about exactly.
okay,
Thank
okay. So as the young man just said, let me stop laughing, please. Okay. So what I want to say is you will now put them like you've created like sections for them. Like, okay, yes, this is how my payment will be handled. You created several APIs for it, right? This is how my search will be handled. You created several APIs for it. You understand? Take for instance now, you can say, still using search, you can say there are some particular words that if it is searched on your app, it will only bring something exactly the same name with that particular search. Let's say someone comes to search for Bugatti. You will not be returning a Bugatti toy car. You would actually return a Bugatti. You understand? And as opposed to if someone searches for iPhone now, you will not just return an iPhone. You return an iPhone charger, an iPhone case, an iPhone, other accessories, AirPods, and the likes. Someone said something. Oh, I'm breaking. Can everybody hear me now? Can everybody hear me now? Okay.
Yeah, we do.
Yeah.
Okay. So you can break it down into sections. So that is why I said APIs are ways to create microservices that allow issues on applications to be isolated. So it means that when you begin to have issues, it's only Fortune that cannot hear me. Everybody can hear me. So Fortune, I hope, yeah, it is recorded. You will probably get a recording. I don't know how the
Yeah,
monitor will play, but you
you
can
can
probably get a
see, I
recording.
can hear you. I can hear you clearly, and yes, of course, you are going to have access to the recorded session.
Okay. So
Yeah.
now we can move on to why APIs, right? So okay, which means I've overtalked. Before APIs, there are monolithic applications that add major drawbacks. The drawbacks that if one part of this application fail, the whole app fail. Ibon, is the whole app fail? I said fails. So the way out gave birth to the concept of APIs. Then APIs provide a more secure way of protecting data on application, which with its authentication features. Yes, that's one of the things API also brings to the table. You know that in a monolithic application, it is quite easy, right? It is very difficult. It is a rigid process to create user permissions on monolithic application, very, very rigid. But in APIs, it is very flexible because when you are creating, like there are some API protocols that we'll briefly discuss. When you are creating, you understand, you would have been assigned some particular flags, like some particular attributes and characters. Like if I'm going to be a normal user, let's say it's a student portal now, I want to register. When I'm signing up, you know, I would have clicked register new students. So when I click register new students, it is an API. I'm already launching a sign up API for a student. As opposed to on that same student portal, on that same school portal rather, on that same school portal, let's say I am now coming in as a lecturer. Register a new lecturer. Once I click the register a new lecturer button, it will not be sending the API to sign up as a student. It will be sending the API to sign up as a lecturer, but the difference will be, it might be the same API on the back end, but the difference will be once I click for students, there will be an auto-populated flag that will show that this person is a student. And that flag that shows that I'm a student already gives me a set of predefined permission. Someone wanted to say something. Okay, let me continue. Can you guys still hear me?
Hello?
Can you guys still hear me? Okay.
Yes.
Yes.
We can hear you.
Yes. So now if I am going to now register as a lecturer, it might be the same API, but there'll be a part that will be auto-populated and say, this is a lecturer's access. So it means the interfaces, we are going to be using the same website, logging in on the same portal, the same login page, but we'll be seeing different things because we have different privileges. That's one of the things API brings with ease, right? Now, and aside that, it also brings security because once you are logging in, this essence of having access token and access privileges is when it is easily implemented in APIs. Now, I forgot to mention the types of APIs that we have in the what's it called? In the first type of API is of the oh, sorry, I'm jumping. We'll get there. So, anyways, the last thing I want to say is that APIs makes it easy to build. In the time of monolithic applications, when you build one application for the web, you have to start again and build for the mobile in case you want to do the mobile. Let's say you're not building native mobile apps. So native mobile apps means apps that you have to go and download on Play Store and App Store. You just want to build an app that you can access on your mobile. When it is monolithic, you understand, you can still use it that way. But if you want to build a monolithic app, right? When you build the web, you have to build the same, as in you'll be writing the backend codes again for the mobile. But when an API is involved, you can use the API that you use to build the web to build the mobile when you want to build the native apps. Do you understand? Let me repeat that. For monolithic apps, you will rewrite your code when you want to write native apps. But when you have APIs, you can use the same API to do a web implementation, to do a desktop implementation, like desktop that you can also download on Microsoft Store or maybe Apple Store on your desktop. You can use the same API, and you can use that same API to build a mobile application. Do you understand? So that is why APIs are good. So now the types of API, we have, I'll only talk about two because these are the most common ones, but there are like 4 now. People interchangeably, they use the word, but they actually serve the same purpose. Do you understand? So we have SOAP. Actually, SOAP, as I then know, was most common in banks. Nigerian banks uses SOAP API a lot because it has a very, very rigid and hard to break security feature. You understand? It has that, but it is not as fast and responsive as REST API. So they still have to, but REST API is secured as well. You understand? But so over time, they had to move to REST API. So SOAP actually means Simple Object Access Protocol. And it is XML. It is actually written in XML, like your body request and your response will be in XML. While REST API is actually in JSON. JSON means JavaScript object notation, and REST means RESTful, means representational state transfer API, right? And it is very easy to use. Now, the tools that you use to test SOAP is on Smart Beer. The ones you use to test REST API is, there are so many of them. I just brought like 3, but the most popular one is Postman, right? And all of them look alike because you must have like the place, your method, your URL would stay. You have to have your headers and authorization. You have to have the body, the prescript, the tests. You have to have all those features there. So so the thing is, what I'm trying to say is that if you know how to use one of the tools, you can easily, over time, relatively use the other one without having too many issues. But the only thing is, once you start using Postman, it becomes difficult to use any other one. Postman is sweet to use, let's not lie. Then the APIs are typically defined as a set of specification, you understand, such as HTTP requests, the hypertext transfer protocol. Now, these HTTP requests are like the bedrock, they are like the husbands to the API concept, which would let us understand why we need to test APIs. Because every HTTP request that you get, they have codes that they return. So if you have like APIs, like you have an API method, let's say a get or a push, a put or a post, or even if it's a delete, there is an expected HTTP code that would refer to a successful API execution. And if you have error, the error code also means something. In this particular video, we'll not be talking about the error codes. It's just to focus on why we test, but we'll still go ahead and still talk about the types of API methods, right? But we'll now talk about why we test it, and that's where I want to quickly get to as fast as possible. So moving on, the REST API methods, we have so many. I think the major ones are like 9: get, put, post, add, trace, patch, delete, options, and connect. You can go ahead and learn more about what the REST does, but the most common ones that you must have seen is get, post, and probably put. Now, let me quickly talk about those 3. You see, get, we do get a lot. Even if you have never tested API before, I will tell you that you have been using a get API almost every day. Who knows how you will use get every day? Who has an idea? Just unmute your mic and say it.
By booking a ride.
Yeah, it's that's not essentially a get. When you are booking a ride, you are doing a get, but eventual booking is not a get. The time you are putting in your destination, but let me give you the most common one before I explain that one. Every day, every time you use Google, you are doing a get. Every time you search, you are doing a get, because you are telling me what get does is from its name. You are fetching results. Fetch me something. Anytime you argue about Ronaldo and Messi, who has the highest goals and all that, the moment you type it on Google and press search, that's a get request. Now, in the booking a ride thing, once you try to put in your address, the point it starts auto suggesting for you addresses that are likely yours. It is already getting it for it is fetching you like related results, right? Now, let's now talk about posts. So now, before I leave get, a successful get method will return a 200 OK. That's the HTTP code it will return. A 200 OK. It means it was successful. Now, let's talk about post. Let's jump put. For post now, let me use the student application portal I talked about. What does post do? if you are trying to sign up on any application, what you are doing there is you are doing a post request because you are creating information, right? Now, that kind of information that you are creating, the ideal HTTP response you will get for it is a 201 created. So for every time you create a new application like that, we'll continue to use the student scenario. So once you've created it, you created your username and password, you signed up, and you went into your email to verify your sign up, good. You've posted. That means you created something. But the next time you come to that portal to log in, you are still doing a post request because you are making a request to have access to login. You are not fetching your login details. You have to supply your details, right? First, you will supply your details to the database. The database will verify your username and password. Then it will accompany it with an access token as a response. And the HTTP code you get for that one is a 200 OK. Right. Now, I've talked about posts in different parts, when you can use posts to create and when you can use posts to gain access. Now, puts. Let's say when you were creating your file on the student portal, let's say you made a mistake on your surname. Like me, let me use myself as an example. My name is Ademola Badmos, but my Badmos has an H. Let's say when I was creating my profile, I mistakenly left out H. So I wanted to modify it. At the point that I'm modifying it, ideally I am using a put request. I am modifying one action. I am using a put request. Right. So I've explained like 3 of it. You can go ahead and learn more about all these methods and how they actually work. But in an ideal Nigerian working environment, the most common ones you see is get and post. And the thing is this, when you learn about API creation, it is because of development convention. Like this is the rule. It is not as if it was written in concrete. I have worked in an organization before. I am not kidding you. Get request was doing the job of post because the person that designed it used get. When you learn how to build APIs, you understand this particular part better. Because the thing is, these things are not just manufactured themselves. Ah, man, I don't have any of my, there was one time I was learning how to build APIs to understand APIs better. I don't have any of it opened. But if you just go online and see a sample API, probably by the ones built with Python, you will understand what I'm saying. All you just needed to do is just change that method. There are methods, they are like, what are methods? Methods are like functions inside the classes, inside the class. So you understand? So they are creating those methods. So you can easily change the method name from get to post, and it will be doing the same thing. But where I'm going to is that the most common ones you see in the Nigerian industry is the get and the post. So post can do the job of a put too. Actually, by default, you can actually make it do it. So you see people do a lot of get and post, and you rarely see the rest. It's only in some maybe multinationals that are in Nigeria that you see that the actual one that is meant for a particular purpose is used. So moving to the next one. Okay, I've explained it. Why am I ahead of my own slide? So now let's talk about it. We're almost there. How many minutes do I have left?
You have about 10 to 15 minutes left.
I will make it. Amen. Amen. So now let us now talk about why we test APIs. The first one, I'll start explaining each one in no particular order. So it reduces the possibilities of defects to a larger extent. So what do I mean by this? So in an ideal environment where you are testing APIs, where you are working, if you test your APIs first, because what the API actually do, like I've said before, it like connects you from one end to the other. Remember the search example. When you're searching on the front end, the API is collecting what your search criteria and it is taking it to request your search criteria from the database. So your API is working like a middleware. Does that make sense? It is working like a middleware between your front end and your back end, right? But when you've tested your APIs first, like let's say you've tested the search API, you have tested the profile creation API, you have tested the payment API, you've tested them. It means that the APIs are working fine. They can actually query the database. What is just needed is let us go and test it when we now put the front end on top of the API. Let us see how it works. Does that make sense? So which means that if all your APIs work and you've even automated it, it means that the chances that when you find bugs, it will be API related has been reduced greatly, or it will be backend related has been reduced greatly. It might mean that it is the way the UI developer has integrated the API that has caused the error most times. Once you've been able to test your API to a larger extent, then it aids better error handling. What do I mean by this? All these HTTP codes I mentioned earlier, there are more. There is 400 unauthorized, no, 400 bad requests, on 401 unauthorized, then there is 500 internal server error. There are so many. How come I can't remember? So there is even 494 not created. But all these error codes, they actually have a meaning. They have some, like if you have 400 bad requests, it means you probably are giving in, let's say you want to log in now, right? And you now put, and let's say the login is supposed to be your username, not email. You're supposed to create a username during creation, and that username and email is the only acceptable login. I mean, username and password is the only acceptable login, not emails. You now supplied an email and your password. That is a bad request because for the username field, it doesn't accept email. You understand? So that is a bad request. Now for unauthorized, let's say the student portal I mentioned, you are a student, you now wanted to log in. But let's say the login feature now has, if you're a student, click this side. If you're a lecturer, click this side. You know you are a student, you have student credentials, you now click lecturer side, right? You now supplied your details. Of course, your details will be carried to the database, but the database will check it against where you want to enter. We realize you don't have access, so it will not authorize you. So that is when you get 401 unauthorized. So when you understand these HTTP codes, it helps you and your development team to handle error better. So you will not expect the UI, the front-end developer, to now use, maybe when you now try to log in on the lecturer's portal, it will now tell you 401 unauthorized. No, it will help, it will write, the front-end developer will interpret that 401 unauthorized into a readable and meaningful error message, like you do not have access to this portal, go to student portal or something. Does that make sense? Then in the case of the bad input request, when you are putting it, when you are putting in email, when you are supposed to use username, the error will be better handled and it will be presented to the user in a meaningful way, like only username is allowed, email or email not allowed. We let the person know that I'm not supposed to insert an email here. Now, it also reduces the cost in testing. What that means is it reduces the time it will take you to test greatly. Because APIs are fast. Imagine if you've tested your APIs manually, you've created tests against them, and you've also automated your APIs. And your APIs run at all times. What that means is that when you want to now test, you can focus on your UI tests because you know that your APIs are being tested 100%, which reduces the time you used to take it will take you to test the whole application. Then it provides the foundation for performance testing. In actual sense, all of you who knows anything about performance testing here would know about JMeter, Blaze meter, and the idea behind Blaze meter particularly is it records the whole process you want to do, stores it in a JMX file, and you can put it into your JMeter. But the actual thing is, when you want to do performance tests, it interacts with your API. Now, what is performance test? Performance test is the test carried out to check the threshold, the stress level, and the performance of your application when an extraneous load of requests is placed on your application. Somebody will say, let me break it down. Now, the thing is, performance test is the test carried out to see how well your application can handle stress. That one is the simpler version. And the only way they do that, the best way to do it is to use the APIs. Let's say they carried all of us like this. We are a group of engineers and want to build a new JAM portal. And we already know that we have over 200 million people in Nigeria. And out of those 200 million people, 70% are admission seekers. So we expect that once they want to come and apply, there will be an influx. So the thing we'll do is we'll carry our APIs and see if people want to log in at the same time. You understand? Let's say sign up. If people want to sign up at the same time, they want to register themselves at the same time, how will our own application handle it? Do we have enough servers to distribute our application so that it will not crash? So we begin to bombard the API faster than it should do. You understand? We'll just carry those API requests, create virtual users with virtual names and everything, start bombarding the sign-up API. We'll first have a base rule that, okay, yes, based on what we've done, we expect that 1,000 users should not crash our system. So our base rule can be, we test it with 1,000. If 1,000 doesn't crash it, then we now say, okay, let's start increasing it by probably another 1,000 or maybe by half 1,000. Maybe we'll start increasing the threshold by 1,500. So we now say another 1,500 requests under 2 minutes. Let's see. And our first intention was under 2 minutes, our application can handle 1,000 requests. That's our assumption, our base rule. We checked it, it worked. We can increase it by 1,500 under the same 2 minutes. If it doesn't work, well, we might say maybe because of latency, the time against the request, let's increase time. Or we may feel that we should be able to achieve at least 5,000 in 2 minutes. Then that takes us to the drawing board. What do we need to do? Is it the way we are indexing in our database that will cause this? Let's see how we can reduce things and factor things. So APIs give you enough foundation for performance testing. Now, when it comes to detection of errors, APIs give you the best way. That's the next point. Easier detection of areas of defects. Hey, Ibon. Areas of defects, not defection. Please close your eyes. Don't be blinded by bullets. So what I'm trying to say here is that using the payment app or the student app, okay, let's use the payment app. Like I said, let's say search is not working. Everybody knows that it is either the search front end or the search API or the database that is wrong. So we don't need to start looking at login that the search is not working. We'll not be looking at login. We already know that there's an API that corresponds to that part. So it is easier to isolate issues and detect and treat them easily. You understand? Then easier detection of security loopholes. Like I said, using that user login as an example, we can also detect our security loopholes using by testing API. Yeah. We will get there. We'll get to questions. Wait, everybody will get to talk. Let me just quickly finish this. I've seen your question. Okay. So now the thing is, for the security loopholes, let me cite an example. This one actually happened. It's a payment application. Now, I tested the API. Every payment you make, whoever is an accounting student or have accounting knowledge knows that for every payment, there is a reference number that is attached to that payment. And that reference number has to be unique to that payment. You understand? So let's say I now generated an invoice to pay for something. I have been given in the API, it was for me to generate an invoice. So I already have a transaction reference for that invoice. But while testing, I was able to use that same transaction reference to buy. The transaction reference on the invoice was to buy something worth 10,000 naira. The invoice was 10,000 naira, but I was able to use that same 10,000 naira invoice to buy something worth 10,000 naira 4 times. You know, that's a loophole. That's a payment loophole. It means if we push that product to production, people will just start cashing away. They just start cashing out. Imagine if that is the logic behind an ATM machine rather. So it means that you can go and withdraw your last card, still go back to the ATM, withdraw more, go back to the ATM, withdraw more, and it will not be reconciled with your account. So when you test APIs, it exposes security loopholes. And I think that brings me to the end of the class. Okay. And okay, you have questions. Please make it short to Barcelona is playing tonight. So anyways, let me start with the first question I can see in the chat. I have a question. What is the best coding language we could learn so as to have the best knowledge of API creation? Let me first advise you, when it comes to coding language, please go with what is comfortable for you. Any coding language that can write a backend application, that can write a function and a class, can write APIs. I'm yet to see any application that cannot write APIs. Any program language that you can use write API. You can use JavaScript to write APIs. You can use Python to write APIs. You can use Java. You can use C#. You can use Ruby. You can use almost anything to write APIs. But go with what you are comfortable with. The same way, when you want to learn automation, just go with the language you